Hello everyone, I'm back from the dead for part 3 of the single stage stock endurance challenge. In the previous videos we launched off from Kerbin and landed on Minmaskilian Pole. In this mission we're going to go land on Bop and then go land on a top secret destination. This is definitely not a standalone video, so if you have not watched part 1 and part 2 of this, I'd recommend that you go do so now. When we left off the previous video, we had just landed on the surface of Pole. Bill has now had time to let the RTG regenerate the electrical batteries, so we're ready to take off. The landing position doesn't give us the nice takeoff ramp that we need, so we're going to let the spaceplane coast to the bottom of this gully before firing up the engines. This ascent will be able to be done off of just the electrical charge from the batteries, as with all the previous maneuvers in this video accepting the ascent from Kerbin. Bill couldn't resist throwing in a couple low passes on the ascent for your viewing enjoyment. I did have some comments in the previous videos that insisted with a strange level of confidence that it made no sense to use the battery banks and I would have been better off either using solar panels or RTGs, and my only response to these is that you just have to do the math. Unless you need to do a lot of Delta V in a single maneuver, batteries are definitely the best way to do a mission like this. So to the people in question, please continue to leave comments on my videos, but I do humbly recommend that you structure it as a question or a suggestion rather than a "you're wrong." Now that we've given our batteries time to regenerate, our next destination will be Bop. While I am normally fond of splitting ejection burns into multiple maneuvers, the entire maneuver from low Pole orbit to Bop is only about 120 meters per second, so we can do it all at once. To continue the theme of answering various questions that I've seen in the chat, yes, it is very taxing on my computer to simulate a craft with 112 ion engines running at once, but no, I don't need a supercomputer. This is done just through turning graphics settings down and letting the computer run at a lot slower than real time. Now that we've reached Bop, I'm going to brake into a captured orbit, and then on the next go around we'll brake down into a low orbit. While we brake into a low Bop orbit and then land, I'm going to answer a question that was asked by Max J and Commander Cloud, among probably a couple other people. And what they asked me was, why didn't I use the heavy liquid fuel first and then the more efficient xenon fuel second? And this is something that seems to make a lot of sense. If you use the lower ISP fuel first and then the higher ISP fuel, the total amount of Delta V that the craft will be capable of is higher. There's two effects that counteract this. The first is that if I do these landings where I'm using the liquid fuel first, I'm doing these landings when the craft is heavier, and then I need a correspondingly greater amount of liquid fuel. The second problem here is that this liquid fuel here is specifically there so I can do TWR intensive maneuvers. If I increase the weight, which is going to happen if I do these maneuvers sooner, when I have more xenon fuel left, and I've had to add more liquid fuel to account for the first effect, I then need to add more thrust. I end up with a trade-off. Yes, there is an advantage to doing the landings that require liquid fuel first. When I ran all the math on how much fuel I was going to need in LKO to do all of the landings that I wanted to do, I got better results when I did the landings that only needed xenon fuel first and then did the more TWR intensive landings where I needed to use liquid fuel second. After landing on Bop, Bill fell out of the cockpit and rolled a strangely long distance. But he did manage to get the flag planted, so all we have to do now is recharge the batteries and get ready for another takeoff. The craft is rotated here by having a lot of friction on the front wheels, but very low friction on the rear wheels, which allows the front of it to act as a pivot. Unlike on the previous launch, the landing spot has given us a nice gentle ascending grade, so we can go right into our takeoff run. No extremely low pass in this ascent, so I'll just fast forward it right into orbit and we'll be ready to go to our next destination. This ejection burn will put our orbit onto an intersection with Tylo, and that will give us our first gravity assist in some time. I'll leave our next landing as a secret for now. I can tell you it is the most popular destination in the game. After some exciting laps of Jool, we're ready and approaching our final gravity assist off of Tylo, which will fling us onto a transfer orbit to our next secret destination. We've now reached Dress, which I know is everyone's favorite planet, and ready to do our injection burn and get ready to land. While the orbital diameters of Jool and Dress's orbits aren't that different in terms of gravitational potential energy, the relative inclination of Dress means that the injection burn is going to be about 600 meters per second, which means we're going to need 3 full charges of the batteries. Most of this burn will have to be done before we've even captured in an orbit of Dress, which I suppose means that we'll fly off into space and never be heard from again. Don't adjust your computer monitors yet. I had thought of this and had planned the first retrograde burn such that after leaving Dress's sphere of influence, we are on an orbit of the Sun that has a 4:3 resonance with Dress's orbit, which means that 3 of our orbits and 4 of Dress's orbits later, we will have another rendezvous with it. After 3 orbits of the Sun, the battery banks have definitely had enough time to fully recharge, and we're ready to capture for real this time. Now that we've captured, we can take our time braking the rest of the way down to low Dress orbit. Now that we've reached low Dress orbit, let's talk a little bit about the landing. I don't have enough TWR from just the ion engines, or enough delta V from the battery packs to do this using just the ion engines, so this will be the first time in the mission, since orbiting Kerbin, that we're going to be using the liquid fuel. When planning this mission, I wanted to make sure that each landing used as little liquid fuel as possible, because it is the heavier fuel. As a result, the philosophy here is to use as much of the ion engines as possible. This is achieved by making sure that I exhaust all of the electrical charge in the battery packs, which means that I've used all of the ion engines that this craft is capable of. We're then just going to be using the liquid fuel to make up the difference between that and what we need to land. I'm going to be using the nuclear engines during the final approach during this landing, when the TWR requirement is the most strenuous. At 210 meters per second surface speed, I fired up the LVN engines and got ready for the final approach. With the surface fast approaching, I think we have time for one more close pass in this video. I couldn't find any super flat parts of Dress, but I did manage to find this part that was both high elevation and flat enough that it wasn't going to break anything. Some of the comments suggested I try adjusting the suspension settings to reduce the amount of bounce on the landings. I did try this, but even using the dampers, I wasn't able to get this to not bounce. If someone else has had a lot of success adjusting landing gear in this manner, please let me know. The takeoff from Dress is going to be left for the next installment in this series. Before I wrap things up, let me explicitly thank everyone who took the time to ask where I had been the last 5 months and why I wasn't making any videos. It's really nice to know how much these meant to everyone, and it definitely inspired me to come back and make this one. For the sign-off, please enjoy the conclusion of the saga of the world's lowest effort vertical takeoff and landing plane.